So it's not just a random mess of supernovae. We actually see that there's a very distinct relationship between how long the light has been traveling towards us and how much the size of the universe has changed. So over here, we've got, this is the size of our universe now. So this doesn't tell us in absolute terms how big the universe is. It just tells us how much the universe has changed in size. So over here, of course, today the universe is its current size. And we can see from these data points that as we go further and further back into time, billions and billions of years ago, that the universe is gradually getting smaller and smaller. So when we go to, about when the Earth was formed, the universe was about 3/4 of, the whole universe was about 3/4 of its current size. So this relationship was first discovered in 1929 by Edwin Hubble and some of his colleagues. We often call this Hubble's law. And for me, I think this is one of the most profound discoveries in cosmology, because it tells us, just by the simple fact that the universe used to be smaller, it tells us some very profound things. It tells us that our universe is expanding, and it tells us that if we keep on going further and further back, how small is the universe going to get? And this was some of the very first observational evidence that our universe started with the Big Bang. Now, if I bring in a little dotted line here, you can see that for billions of years, the universe was just expanding at a kind of pretty steady rate. And really, ever since this relationship was discovered, way back in 1929, this was pretty much what we expected, and we thought eventually the universe was going to stop expanding, and kind of like that roller coaster reaching the top of the hill, it was going to stop expanding and then contract and then come back, and we thought the universe might end with a big crunch. But in the late 90s, there was a big surprise, and you can see it right here, that the universe is steadily expanding, and then what's this, about 3-4 billion years ago? Yeah. It actually gets bigger and bigger, faster and faster. Does anybody know what we call this effect? People might have heard of this. Expansion. So we actually call this effect accelerated expansion due to dark energy. We really have no idea what is causing this, but it's a really big mystery. It's exactly the same as if you imagine that roller coaster traveling up the hill. You'd expect it to get slower and slower. How strange would it be if it got faster and faster as it was traveling higher and higher up the hill? That's what this data is telling us. So it's a really big mystery, and nobody knows the explanation. But it's this data which has contributed a huge amount to this picture of our universe. So this is a kind of summary of what's called our standard model of the universe. And you can kind of see here in this illustration that it's expanding at a gradual rate for a long time. And then in the more recent universe, that expansion suddenly starts accelerating. And we can tell by extrapolating this and other kind of data that our universe is nearly 14 billion years old. Now we think it's dominated by this dark energy expansion.